In this class, we will study what exactly it means when we say a matrix is a diagonal matrix. Now, let us consider a matrix A, which is of order 2 by 2. It means it has 2 rows and 2 columns, 2, 3, 5, 6. If you observe this matrix, it has elements placed everywhere of its structure. Now, given the same matrix A, if this matrix has just elements along its diagonal, for example, this matrix has got 2 diagonals. One is the leading diagonal which flows from the top left corner to the lower right, and it has another diagonal which flows from the lower left to the top right. Now, if the elements of this matrix are just arranged in one of these diagonals, say for example 2 and 6, and other points are just filled with 0, then such a matrix is called a diagonal matrix. So this is one form of the diagonal matrix. We can have the other form also, say 5 and 3, the other elements being 0. In both the cases, the order of A is 2 by 2. It has 2 rows and 2 columns. But the only difference is we find the elements being featured along the diagonal. Diagonal matrix are always square matrix. That is to say, they have equal number of rows and columns. Another illustration can be a matrix of this fashion, say 3, 2, 1. The other elements are just zeros. The order of this matrix is 3 by 3. That is to say that it has 3 rows, row 1, row 2, row 3, and 3 columns, column 1, column 2, column 3. But the elements are just featured along its diagonal. So this matrix can be having elements either in this fashion, or this is also another way of representing the diagonal matrix. Say for example 3, 2, minus 1, 0, 0, 0, 0, 0, 0. So this is a diagonal matrix which flows from lower left to top right. In this case it is top left to lower right. So there are many forms of diagonal matrix. So whenever you see entries featuring in either in one of the diagonals that I've showed, then such a matrix is what is called as the diagonal matrix.